Okay, good morning everyone. We are just discussing this chapter number 5 of CPU scheduling, where we were discussing the various scheduling algorithms. We have already discussed first come, first serve, then shortest job first, and then shortest remaining time first, which is the preemptive version of SJF. And today we will focus on the next two scheduling algorithms. The very first is priority scheduling, and second one is the round robin scheduling, which is another very interesting concept used in the time sharing systems. So I hope the algorithms which we have read till now are very much clear to you. Okay, so moving further for priority scheduling. So in priority scheduling, each process is having a priority as the name suggests. So a priority number, which is generally an integer, is associated with each process, and the CPU is allocated to the process with the highest priority. So the process which will be having highest priority will be assigned to the CPU first, after then the next priority process, then the next priority process, and in the last, the process having the least priority or the lowest priority will be assigned to the CPU. And the concept can be anything, but mostly we consider that the smallest, the integer, the highest, the priority. So it is just like we used to calculate the rank. So जितना कम रैंक होता है उतना अच्छा परफॉर्मेंस माना जाता है. So in that case, here also the priority number जितना आपका इंटीजर लीस्ट होगा, लेस होगा, सबसे कम इंटीजर वाले की हाईएस्ट प्रायोरिटी होगी. And equal priority processes are scheduled in FCFS order. So same concept here as we have learned in SJF also. If two processes have a tie that they have the same burst time, the remaining burst time, then they will be processed in the first come first serve order. Similarly, there is a possibility that two or more than two processes may have the same priority. So in that particular case, the process that will arrive in the RAM first will get the CPU first. And just like shortest job first, this priority scheduling can also be either preemptive or it can be non-preemptive also. And as we have learned, FCFS is always non-preemptive. SJF can be preemptive or can be non-preemptive. Similarly, priority scheduling can either be preemptive or it can be non-preemptive also. And there is one major problem with this priority scheduling algorithm, which is known as starvation, or it is also known as indefinite blocking. So what is this starvation? It is possible that a low priority process may never execute. ऐसा हो सकता है कि आपके पास 10 processes हों रैम में एक टाइम में, और जो सबसे लोएस्ट प्रायोरिटी का प्रोसेस है, सपोज 10 प्रायोरिटी है, उसकी टर्न कभी भी नहीं आए, वो कभी भी एग्जीक्यूट ना हो सकता है कि बार बार रैम में जो नेक्स्ट प्रोसेसेस आ रहे हैं वो उससे ज़्यादा प्रायोरिटी के हों, ज़्यादा इंपॉर्टेंस के हों, तो वो प्रोसेस हमेशा रेडी स्टेट में ही रहे, उसको कभी भी CPU एलोकेट ना हो. And the problem for this starvation is known as aging. So aging is the solution to the starvation or indefinite blocking. And in aging, we use a technique, we use a mechanism to increase the priority of the processes with respect to time. So हम एक aging solution लगा सकते हैं कि हर एक मिनट के बाद या हर 10 सेकंड के बाद उस प्रोसेस की, सभी प्रोसेसेस की प्रायोरिटी या उस प्रोसेस की प्रायोरिटी एक एक से इंक्रीज हो जाए, सो दैट कुछ टाइम के बाद उस प्रोसेस को डेफिनेटली CPU एलोकेट हो जाए. सो दीज आर सम ऑफ द बेसिक कंसेप्ट्स ऑफ प्रायोरिटी शेड्यूलिंग, एंड दिस इज द एग्जांपल व्हिच यू पीपल हैव टू सॉल्व, and I hope now you understand how you have to solve such kind of things. So here we have 3 columns, and this is the example of non-preemptive, where we do not have any concept of arrival time, and we will just solve this numerical or make the Gantt chart according to the given information. The first column we have 5 different processes from P1 to P5. In second column we have their burst times. That means P1 process requires 10 milliseconds to execute on the CPU. P2 and P4 requires 1 millisecond. P3 requires 2 milliseconds, and P5 process requires 5 milliseconds on the CPU. And along with these 2 columns, a new column is there which were not there in the previous algorithms, because this scheduling algorithm is priority scheduling. So we have the priority associated with each process. So as you can see, there are 5 processes, and जितना कम priority number होगा, integer होगा, उतनी ही highest priority होगी. That means P2 process is having the highest priority because priority number is 1, whereas the process P4 is having the lowest priority because here the priority of process P4 is 5. So I hope all of you can make the Gantt chart. So यहाँ पे non-preemptive version है, so we do not have to use that much mind or as well as concept. So we just have to make the Gantt chart according to the priorities. So we will assume that all the processes arrives at the same time in the RAM, and all of them have arrival time of 0. So we just have to focus on the priority number, and we have to make the Gantt chart as according. So I am here on the blackboard just sharing this numerical. I'm just solving it for you, and now I hope all of you can also make the Gantt chart according to the given problem. You have learned how to make the Gantt chart. So this is the problem. As you can see, we have 5 processes, their burst time and their priority. So Gantt chart always starts with 0, as we all know, and definitely the process P2 is having the highest priority 1. So that means first of all process P2 will execute, and P2 requires only 1 millisecond onto the CPU. After that we have the priority of process P5. So P5 process requires 5 milliseconds. So from 1 to 6 milliseconds this process P5 will execute. Then next priority is of P1. So P1 requires 10. It requires 10 milliseconds to execute, and after P1 we will be having P3. P3 requires 4 milliseconds. So this will be from 16 to 20, and last priority is of P4, which further requires only 1 millisecond. So that means from 20 to 21 the process P4 will take the CPU. So this will be the Gantt chart, and if we calculate the burst time, 10, 1, 11, 13, 13 plus 1, 14 and 19. Okay, so this is 10 plus 1.
सर P3 16 से 20 नहीं होगा सर, 16 से 18 होगा.
Okay, the burst time of P3 is 2. I have just calculated the priority. Okay, and for correcting me, so P3 requires only 2 milliseconds. So it will be from 16 to 18. And then we have P4, which requires only 1 millisecond, that is from 18 to 19. So 5 plus 1, 6, 8, 9, and 9 plus 10, 19. And again, I am here having this 19. And now hope I can, you people can just complete this table. So the completion time of process P1 is 16. Then P2 process is 1. Then P3 requires, the completion time is 18. For P4 it is 19. And for P5 it is 6. So I hope all of you can just make it very easily now. And if we talk about turnaround time, so we do not have here arrival time. So we will assume that arrival time for all the processes is 0. So it will be same as the turnaround, the completion time. And if we talk about this waiting time, so waiting time is always turnaround time minus burst time. So it will be 6, it will be 0, it will be 16, then 18, and then 1. So what about the average turnaround time? 16 plus 1, 17, 17 and 18, 35, 35, and 19 is 54, 60, 60 by 5. I think so. Okay, so 12 is the answer given by Anjali Sharma, and 8.2 is the average waiting time. Okay, or any other student who has solved, so it will be 60 by 5. It will be 12 milliseconds. And what about this? 6 plus 16, 22, 22 plus 18 is 40, 41 divided by 5. So it will will be 8.2 milliseconds will be the average waiting time. Okay, Yash has also answered. So this is how we have to calculate the things, and I hope all of you now can easily make the Gantt chart and can solve it also. So just let me go back to the slides and let's see what is the answer of this. Okay, so this was the question and अराइवल टाइम नहीं गिवन है और हमें गिवन भी होगा कि ये नॉन प्रीएम्प्टिव है सो वी जस्ट हैव टू मेक द गैंट चार्ट एज अकॉर्डिंग टू द प्रायोरिटी शेड्यूलिंग ओके सो दिस इज द गैंट चार्ट and we can just compare it what we have made. So initially the process P2 is having the highest priority, so it will be executed first, followed by P5, then P1, then P3, then P4. And they have just directly solved this average waiting time, which is 8.2, and I hope we also were getting the same average waiting time when we have solved it. So this is how we have to work with this priority scheduling, and non preemptive version I am not discussing. You can just take